Okay, so I want to talk to you about Chapter 4. Topic of Chapter 4 is describing bivariate numerical data. Important topics in this chapter include correlation, linear regression, fitting a line to bivariate data, and assessing the fit of a line, as well as describing linear relationships and making predictions, putting it all together. And there's some common mistakes that are to be avoided, and that's discussed in the last section here in the chapter. If you take a look at the first page here, we've got a picture of a crime scene, and they've got a real good example here to help motivate the main topics of the chapter. And let's take a look at that right now. What can you learn from bivariate numerical data? A good place to start is with a scatter plot of the data. If it appears that two variables that define the data set are related, it may be possible to describe the relationship in a way that allows you to predict the value of one variable based on the value of the other. For example, if there is a relationship between a blood test measure and age, and you could describe that relationship mathematically, it might be possible to predict the age of a crime victim. If you can describe the relationship between fuel efficiency of a car based on its weight, you could predict the fuel efficiency of a car based on its weight. In this chapter, you're going to see how that's accomplished. So I want to start with a very brief review of linear equations. This is some prerequisite information for the class. And I want you to recall what a scatter plot is, and I'm going to show you how to do graph one of those on the calculator. And so you can look for linear trends there. So let's go ahead and take a look at what's over here. A bivariate data set consists of measurements or observations on two variables x and y. So if, for example, you have 10 subjects participating in your study and you gather two numerical variables on those subjects, say height and weight, then you've got an x data set and a y data set, or a bivariate data set. You've got two numerical variables. You've got what's called a bivariate data set. In this chapter, you will be studying the simplest form of regression, called linear regression, with one independent variable, x. This involves data that fits a line in two dimensions. You will also study correlation, which measures how strong the relationship is. So in this video, I'm just going to briefly give you a review of linear equations, and we're going to talk about correlation, what it is, and how it's used to measure the strength and direction of a linear relationship between two variables, x and y, in a bivariate data set. Linear regression for two variables, this is a topic we will get to later, is based on a linear equation with one independent variable. And in statistics, that equation has this form: y equals a plus bx. And for this equation, a and b are constant numbers, so they're numbers that are fixed, constant, or they're just pure numbers. The variables here will be x and y. The variable x, recall that that's referred to as the independent variable, and y is called the dependent variable. Typically, you choose a value to substitute for the independent variable and solve for the dependent variable. So what they're saying here is you can get solutions to this equation, and those solutions will be ordered pairs of numbers, x comma y. And a way to get any ordered pair is to put a value in for x and then find the resulting y. Here's some examples of linear equations. Y equals 3 plus 2x. Y equals negative 0.01 plus 1.2x. Does this look like it's a linear equation down here? Is that a linear equation right there? They're supposed to be in the form y equals a plus bx. And we're going to say, yeah, that is a linear equation. And it's something of the form this right here. And if you needed to convince yourself that, hey, there needs to be a plus sign here and there's not one here, and that's linear, then you just use the definition of subtraction. Of course, you could just rewrite this linear equation here as such. And of course, we remember that the graph of a linear equation of the form y equals a plus bx is a straight line in 2 dimensions. Any line that is not vertical can be described by this equation right here. So here's a brief example from algebra. You may recall how to do this one. They want us to graph this equation, -1 plus 2x is what y is equal to. There's a number of ways to do the graphing. If you have to graph this by hand, there's 3 different methods that we usually present. And I think what I'll do is I'll just go ahead and use one of those methods now. I'll make a table of x and y values, which will give me ordered paired solutions to the equation. And of course, that infinite set of ordered pair solutions, when you graph them, will form a line in 2 dimensions. So one way to do this is to pick values of x and then use the equation to solve for y. So I'll go ahead and select -2, 0, and 2 for the x values, and then I'll use the equation to solve for y. So when x is equal to -2, what's the y value here? Well, I'm going to put -2 in for x, and then that gives me -2 times 2, which is -4, and then -4 plus -1 is -5. Okay, so if you have to see that work, it just looks like this. We're going to use the order of operations to simplify the expression on the right side. And the order of operations dictates that we must multiply before we add. So we're going to get that this is -1 plus a -4. And of course, when you add 2 negatives, you should get back a negative. So that's how we got the -5 there. And that gives us a point on the graph, -2, 5. And then playing the same game down here, when x is equal to 0, we just multiply 0 times 2, that gives us 0. And then 0 plus a -1 is just, of course, -1. So that'll give us another ordered pair solution to the equation. And then finally, we'll use 2 for x here. Put 2 in for x, and then 2 times 2 is 4. And then 4 plus a -1 is 3. So that gives us 3 ordered paired solutions, or 3 points on the graph of the line. And then, of course, I got a ruler here somewhere. If I don't have one, I just use a straight edge of a piece of paper. That always works just fine. So I've got my coordinate plane drawing there, and I'm just going to locate the 3 points after I lay down a a grid here. So let's say that this is 1 on the x-axis, that's 2, and so on, minus 1 over here, and negative 2. Okay, so that's probably good enough. So now the first point is negative 2 comma negative 5. So from the origin point, I'm going to move down the x-axis to negative 2, and then I'm going to move down in the y direction to where the location of negative 5 is along the y-axis, and I'm going to throw a point down. Then the next point is 0 comma 1. So from the origin, I travel 0 steps in the x direction, and I'm going to travel 1 step down in the y direction, so that places me right here along the x-axis. And of course, that's the location of the y-intercept, what's called the y-intercept for the equation, or for the line. That's the point at which that's the point at which the equation intersects the y-axis. So then finally this last point, 2 comma 3, I locate that point by starting at the origin, moving down 2 spaces on the x-axis, and then up 3, and then I lay another point down, and it looks like I've got 3 points there lining up in a line, so that I've probably done things correctly. I should probably double check, but I'm going to go ahead and let it ride this time. And that's the graph of the equation. And the reason why it's a smooth curve, recall, is because if you put in this column right here, if you put in the x column the entire infinite set of real numbers, it would take you infinite time to do it, but you could find the infinite set of y values that are paired with that through this equation, and by doing the input value for x and solving for y. Once you graph that infinite set of points, they'll map themselves out in a smooth curve in the shape of a line. Okay, so that's something you probably remember from algebra. We'll try not to bore you here by doing too much review. Here's a word problem on linear equations. Let's take a look at it, and I'll show you how to do it. So we're told that Aaron's word processing service does word processing. So they type up reports and whatnot. The rate for services is $32 per hour plus a $31.50 one-time charge. The total cost to a consumer depends on the number of hours it takes to complete the job. Find the equation, so we've got to find an equation that expresses the total cost in terms of the number of hours required to complete the job. So here, remember x is called the independent variable, and y is of course the dependent variable. And they're telling us that right here, total cost depends on number of hours. Okay, so that means that the y variable will be total cost, and the x will be your number of hours worked. Okay, so we're looking to find an equation that's of this form: some number a, y equals some number a plus bx, And so if we have the numbers A and B, we're done. We've got the equation that we need. And one way to do this is to do the following. Let's see here, after 1 hour, total cost is y equals and think about what's going on here. We're charging a one-time fee of $31.50. And so the total cost will be $31.50, right? The one-time charge, plus $32. And so that's going to come out to, I guess, let's see here, $63.50. And after 2 hours, total cost is y equals $31, $31.50 plus $32 per hour times 2 hours. And that's going to come out to, let's see here, $95.50 if I did my math right, my arithmetic. And after 3 hours, right, total cost is y equals $31.50 for the flat fee, just for showing up, and then plus $32 per hour times 3 hours. Okay. So, and how much will that be? Let's see here. And we're going to get $127.50. And so once you try to calculate a sequence of costs for, say, some sequential hours here, right, after 4 hours, you start to see the equation there. The total cost would be y equals $31.50 plus $32 per hour times 4 hours. So we're developing a pattern in here if you think about cost, and that pattern is just going to be a linear pattern. And if you continue this pattern onwards, after 5 hours, after 6 hours, and so on, you're going to get the linear equation y equals 31.5 or $31.50, $31.50 plus $32 per hour times x. Okay, or just simply y equals 31.5 plus 32x. So that's the equation that they were looking for. So in terms of cost, in terms of total cost here in this application, you've got a fixed cost, a one-time charge, and that's what your A ends up being, or your constant ends up being. And you have a variable cost, which is BX, or $32 per hour, or $32 per X. So the answer we should have gotten here was this. Okay, let's go ahead and move on. and take a look at another example. So in this example, Emma's Extreme Sports hires hang gliding instructors to pays them a fee of $50 per class, as well as $20 per student in the class. The total cost Emma pays depends on the number of students in the class. Find the equation that expresses the total cost in terms of the number of students in a class. So the equation here, the y value ought to be the amount that Emma is paying to an instructor. And of course, that is going to depend on number of students in the class, and then plus the flat fee here. So quick answer is y equals $50 would be your fixed cost. And then your variable cost will be $20 per hour. So $20 for every X, or times X here. So that should be what we should get. If you try to think about doing the problem the way I did it before, with the previous example, I think you're going to see that will lead you to this equation. So we're talking about linear equations, we're talking about their graphs, and recall some of the characteristics of the linear equation here. This, in particular, the slope and the y-intercept of a linear equation. So when you have this linear equation, in statistics it's going to be in this form, y equals a plus bx, and here the number b will represent the slope of the line, and the number a, the fixed cost, will represent the y-intercept, or the location on the y-axis where the graph of the line will intersect the y-axis. From algebra, recall that the slope, remember what the slope of a line is, it is a number that describes the steepness of a line, and it's also a rate of change. It's a rate. So if you go back to the last two examples ago here, and that was this problem here, Aaron's word processing. The fixed rate was $32 per, $31.50, and then the rate for services that was variable was $32 per hour. And so your slope here would be this number, 32. But also, if you think about the units, the slope is a rate. So the slope is always a rate of change between x and y, and it also measures the steepness of a line. And of course, your y-intercept is the coordinate point, or coordinate of the point 0, a, where the line crosses the y-axis. Okay, so recall from algebra, there's three different pictures here. Okay, three different possible graphs of the linear equation. And if b is greater than 0, so if your slope is positive, then your line will look something like this, where it's trending upwards from left to right. If your slope b is equal to 0, then your line has no slope, and therefore the graph will be horizontal. Steepness of the line will be 0. And if b is less than 0, or in other words, if b is negative, if the slope is negative, if the rate is negative, if the rate is decreasing, then the slopes downward to the right. You're going to get a line similar to this, where it slopes downward when you look at it from left to right. Okay, so that's something about the slope, and there was something else I wanted to show you here about the slope. Here's some GeoGebra app that I found that Tim Brzezinski made. It's kind of neat. And you can use this to quiz yourself on whether or not the slope of a line is positive, negative, zero, or undefined. One thing that we left out here, back over here, is that there's really a fourth case that if you have a graph of a vertical line, okay, then we say that this, oops, let me get over here. Then we say that the slope is undefined. So if I want to make a fourth graph here, it would be the graph of a vertical line, and the slope is undefined or infinite. Okay, so another way of saying this is if B is undefined, the slope is infinite, and you have a vertical line. Okay, so back over here to this GeoGebra thing, applet or whatever the heck it's called. It's kind of nice. Look at this thing. Now take a look at this line right here. Is the slope positive, negative, zero, or undefined? And of course, I could put this. There we go. Well, clearly the slope would be negative, right? Because the line's trending. Whoops, I guess I pressed new. So I'm going to click on negative here and check my answer. And of course, that's correct. I can get a new problem. What's the slope of that line? It's trending upwards from left to right, so it's positive. And of course, I got that correct. And what about this line here? Does that look like it's horizontal? Kind of looks like it is. It's horizontal. And so therefore, my slope would be 0. And that looks correct. It's kind of a neat little applet here. You can test yourself on your knowledge of the slope, of inspecting a graph of a line and then determining whether the slope is positive, negative, undefined, or 0. So moving right along here to one more example. And then we'll start getting into the statistics of all this. So right over here, example 4, Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $20 plus $15 per hour of tutoring. A linear equation that expresses the total amount of money that Svetlana earns, so her revenue, for each session she tutors is given by this linear equation, y equals $25 plus $15 for every x, or 15x. And this time the question is, what is the independent and dependent variables? And then follow-up question, what is the y-intercept and what is the slope? Interpret them using complete sentences. And so here's the solution. The independent variable is always x. And here that would be the number of hours that Svetlana tutors. And the dependent variable would be her revenue, the total amount in dollars that she earns for each tutoring session. Your y-intercept is always the number a, the constant number, 25. And what does this represent? It represents, okay, look, when x is 0, she just gets there to the tutoring appointment and hasn't started tutoring, and she gets a $25 fee. So at the start of the tutoring session, when x is 0, Svetlana earns a one-time fee of $25. And of course, we know the slope is the number next to x, which is 15. This is a rate. And of course, the rate here is $15 for each hour that she tutors. So that's a brief tutorial about linear equations.